This is the screencast for section 6.1, example 7. We're going to construct a slope field for a non-exact differential equation. Now this time we're going to use a calculator to construct this slope field for the differential equation dy dx equals x plus y, so a parametric maybe situation. And we're going to sketch a graph of the particular solution that passes through the point 2, 0. So we don't need to come up with the equation, we just need to sketch it. So first I'm going to go to my calculator. And before I type in the equation x plus y, I'm going to hit zoom 6 or whatever window I want it to be on. Zoom 6 will be fine for this situation because we're using the point 2, 0, so that'll definitely be in there. But you want to hit zoom first, change your window first, because x plus y won't be able to be graphed. So that would create an error. So I set the window first, and now I want to put in x plus y. And now I quit out of there, don't graph it, and I go to my program. I have number 4 as slope field, hit enter, and now it's going to draw a slope field using my calculator. So now we need to sketch the graph of the particular solution that passes through the point 2, 0. Alright, so let's see, 1, 2, 0 is right here. So this particular solution is going to kind of, I don't know, go with these tangent lines. I mean, that's a pretty good sketch. It doesn't have to be exactly accurate, but I can see that my tangent lines do kind of direct where each of the little mini slopes or the curve of this graph is going. Then I'll try problem number 35. Says match the differential equation with the appropriate slope field, then use the slope field to sketch the graph of the particular solution through the highlighted point 3, 2. All slope fields are shown in that particular window. Okay, so dy dx. Now of course I know the derivative is x, so the antiderivative is going to be 1/2 x squared. I could probably see that, but let's look at some analysis first. So dy dx, well, the slope is always going to equal the x value, so that's something to keep in mind. So that means when x equals 0, the slope is 0. When x is greater than 0, the slope is greater than 0. When x is less than 0, the slope is less than 0. So let's see here. First of all, at x equals 0, that's not going to happen with a. I can't really tell with b. It looks like vertical, otherwise it would have horizontal slopes. So I'm going to say no with B. With C is definitely possible, and if we look to the right, those are positive slopes where x is greater than 0. The left has negative slopes where x is less than 0. So C is definitely possible. Let's just keep checking. These are not 0 at x equals 0. Neither are these. These are, but then I have some negative slopes to the right and some positive slopes. So that would not be correct, and these would not be correct. So my answer is C, and now I need to sketch the graph that passes through this highlighted point right here. So I'm going to sketch that using the little tangent lines. Looks like be that kind of a parabola. So pretty good parabola there. Again, pretty accurate using the tangent lines. It's sometimes a little difficult to see where they would go, but that is definitely a good sketch.